So here's my simple explanation of climate change for anyone who's interested in it. There's a reason we say climate change and not really global warming anymore, because certain areas will cool, certain areas will get warmer, and nothing's really uniform. So, first of all, I'm just going to be basic generalities. Not going to try and make anything complicated here, thing like that. So, first you have solar radiation emitted by the sun, light. So that comes through the atmosphere and makes contact with the surface. Now, there's something called albedo, which is reflectivity. If you have a high albedo or high reflectivity, then it is going to reflect the light back off of the surface and back into space. You have a low albedo, you are typically a darker surface, you are then going to absorb that light, a certain percentage of it anyways, and then you are going to re-emit the light after you have converted it to a lower wavelength, thermal infrared, which is heat. So we have three greenhouse gases that predominate. These greenhouse gases are carbon dioxide, which is CO2, methane, which is CH4, and H2O, which is water vapor. Now, we don't hear about water vapor too much, but you've got CO2 predominantly from man-made pollution or burning of vegetation, which is a huge issue with deforestation and wildfires out west. We have methane, which is a stronger greenhouse gas than CO2 because of its molecular structure. This is predominantly from our landfills, typically just any kind of waste, as well as it is a byproduct of our livestock system. So more developed, richer countries like the United States has an abundance of livestock that we use for milk and dairy products, as well as you eat a lot more meat products than other lower income countries do. And our support of this huge livestock system produces insane amounts of methane that are pumped into our atmosphere every year as well. So this also contributes to this increase in greenhouse gases. And then you have water vapor that comes in there. And these greenhouse gases that are all in the atmosphere here trap the heat in like a greenhouse. If anyone's ever walked into a greenhouse, you see how humid it kind of feels in there. This is really why we call it the greenhouse effect. These gases are good at trapping this thermal infrared radiation. So it traps it in here and keeps the planet warm. Now, normally, this would be considered a good thing. That's because without these greenhouse gases, all our heat would escape back out of space and our planet would be very cold and we wouldn't be able to live. So, what these greenhouse gases do is they allow for life to form. However, too much, it gets too hot. Too much heat, you can't live in certain situations. That whether that's directly through it denaturing the proteins in your body and you burning up, or organs shutting down and failing, to less drastic things, but it being too warm for you to be able to produce enough food for you to survive, or being too warm to find accessible water that hasn't evaporated. So, and that's really in that evaporation process is actually where water comes in as well as a greenhouse gas. Water is actually the strongest greenhouse gas there is, and with more heat in the atmosphere, there's more water evaporated and therefore more water vapor, starting this positive loop. So this is the general. There's a little bit. It goes a little bit deeper, but this is the general science behind global heating of the atmosphere. Now we say it's not going to heat generally up everywhere because different atmospheric processes, there's different because of jet streams and the way it's positioned, or you've got different areas that heat differently because of landforms, like different topographical regions, like areas that have mountains, whether you're the windward side or the wayward side, or whether you are in a flat region, your elevation matters. So all these different things come into play. So whether you're a coastal or an inland area, all these things really come into play. However, this increased heating, you will see if you look towards California out west, they've been dry for years and it's getting even worse. The wildfires are lasting longer, they're burning hotter. These are creating more desert-like conditions. And typically these burns are healthy for the environment. They allow it to establish primary growth. This primary growth grows into new lush forests and helps return nutrients to the soil. These burns typically allow certain seeds of trees to germinate and then grow. However, the increase in temperature and increasing in frequency of these fires are destroying these seeds and destroying this primary growth. So it's not allowed to reestablish itself. It just is left as a desert-like wasteland. Also, it's destroying agricultural area, which is really bad if you like food like I do. So this is another concern, is access to food, even here in the United States. So it's definitely something that everyone should really be paying attention to. So another thing is with global warming is with the ice cap melts. So with the ice melting in the higher latitude areas, this ice, so ice first of all has a higher reflectivity than liquid water. So therefore, ice reflects a lot of light back into space, where water then absorbs it and then re-emits more infrared radiation. So you've got more melting ice, you've got more water, more dark surface water, which expands under heat, which means there's more surface area for it to cover as well, means more infrared or heat that is emitted from the water, furthering the cycle. So more heat means even more melting of the ice caps then, and that adds more heat to the atmosphere, more melting of the ice caps, more water to the ocean, more heat, and it just keeps going in this never-ending loop. There's another issue to worry about with this. It's called the thermohaline circulation cycle. So thermohaline circulation refers to the temperature of the ocean water and its salinity. Salinity is just salt content. So the salt content is thought to control the currents. So with melting glacial ice, this water becomes more dilute in terms of salt content. Therefore, it reaches more of an equilibrium state. So it's not pulling salt lacking water to areas of high salt content. And it's not, therefore, with all this dilution, you're not also moving hot temperatured waters to colder temperature waters at higher latitudes. So everything's kind of staying put. Without this movement of water, of warm waters to cooler waters areas, you're going to have storm systems, which hurricanes feed off the temperature of ocean water, that are going to stay more prevalent in these hot areas, and they might become more frequent and more drastic, and these regions are going to dry out more quickly as well. And then you'll get colder regions in the higher latitude areas as well. It's actually believed that thermohaline circulation actually stopped and has caused at least one ice age in the past, and this is through paleoclimatological research, which just refers to historical climatology research. So it's thought that had caused that in the past as well. Another issue with melting glacial ice is that usually glaciers reform every year. And there's certain communities that lean on this melting, this reformation of glaciers, and then it's melt every year for water. So that's always nice. They depend on some melt for their water access. Now, however, with too much melt in greater overall average heating, these glaciers don't reform. Therefore, after a certain period of time, they're not getting any more water every year because it melted one year, it's all gone, glaciers are not reforming, or they're not reforming to the extent at which they usually do. So they're not getting as much water. So there's those issues with that. Increased heating, of course. Then we can talk about the urban heat island effect. Climate change, if you want to talk the human side as well, we have our urban areas, which, as I mentioned, are a lot of dark asphalt, concrete, and everything, so they heat more as well. So these areas actually stay warmer also. So because of that, you have unhealthy conditions for living in these urban areas as well because of the increased heating. Now lots of urban areas are by water as well, so this water adds humidity to that factor as well, and then you've got even more heating because of the humidity. With the expected rise, I think there is an expected rise of several meters. I think the current estimates is around a 20-foot global rise in sea level. So this will flood coastal communities. For example, whether that's long-term flooding or short-term flooding based on storms. Hurricane Katrina, for example, flooded an area the size of Manhattan. So you can, if you think about that, that was just from Hurricane Katrina. Now imagine a 20-foot sea level rise overall. So you've got coastal area things to worry about. You have these urban heating issues, which we could deal with. You've got all of this concrete and everything that's out here and visible. If we just simply put some green urbanization tactics to use, and by that I mean just go in and we start implementing these into cities now instead of all of this bureaucratic debate. We could put vegetation everywhere, which, although having a surprisingly low albedo, is still much higher albedo than dark surface area concrete asphalt. So not only would these cool down the urban areas, so they would block the asphalt, concrete, things like that, and cool down the temperatures in these areas, as well as they naturally filter out the air, so they could filter pollutants out of the atmosphere, making the air cleaner to breathe, as well as they could help retain water. And all this water that collects on these buildings and the concrete, asphalt, all of that, taking all the pollutants off these hard surfaces and carrying them into water bodies or agricultural soils, things like that, they could slowly filter out through this urban vegetation, making soil erosion around these urban areas less severe, as well as you could save this water and potentially use it for and filter it out for drinking purposes, for showering purposes, an array of different things that you could do with saving water in this way, as well as decreasing heat, as mentioned. There is many other things I could talk about with climate change. I don't want to sit on here forever, but I hope I could give you a good brief overview